Hello, everyone. Today we're going to talk about ellipses. What is an ellipse? Let's look at the geometrical definition of an ellipse. An ellipse is a set of all points in the plane, the sum of whose distances from two fixed points is a constant. How it's going to look in real life? Well, let's first set up two fixed points. For example, fixed point number 1 and fixed point number 2. I'm going to label this as F1 and this is F2. F1 is going to be focus 1 and F2 is going to be focus 2. Now, what I'm going to do, guys, I'm going to take a string. String is just like a kind of certain like piece I will cut, and I'll cut a piece which is a little bit longer than the distance between focal points. Like, so the string is going to look like this, okay? That's going to be the string. Now, what I'm going to do, guys, I'm going to use my pencil and I'm going to put it somewhere over here in a string, and I'm going to stretch it. So now the string is going to be stretched, and that's going to look like, it's going to make something like a angle over here. So what I'm going to do, I'm going to maybe let me kind of erase unstretched string and make it stretched. Give me a second. So I'm going to erase this unstretched one and go back and make it stretched. Oh no, let's imagine that it's going to be stretched up to here. Okay, so now my string is going to look like this. Over here, it's connected to my pins. And here is my pencil. I'm going to draw a little tiny pencil so you can see it, but actually the pencil is going to be like my E-pen, right? So what is going to happen if I start moving my pencil? Well, because my pencil is going to be restricted by a string, it's going to give me a point a little bit below over here, for example. I move it over here, from here to here, right? And then I'm going to start moving it further, and point eventually is going to become over here. Still, my pencil is restrained by a string, so it sits over here in the corner, and I'm kind of trying to check how far I can reach with my pencil inside of the string around these 2 points. Well, one more time, and I'm going to have something like this, and I'm going to have a bunch of points, right? What is going to be special for all these points? Well, because a string does not change its length, all like sum of the distances, for example, this distance plus this distance, I'm going to label this distance 1 and this distance 2. Distance 1 plus distance 2 is going to be equal to the length of a string. I'm going to label it as 2a. Well, a is going to be just half of this length. I'll explain later why it's 2a, not just L, okay? And if I consider a different point, for example, this one, right? And kind of consider D1, oh, sorry, let me make it more narrow. So go back. If I consider like D1 here, over here, and the second length is going to be D2, the sum of this D1 plus D2 for a different point, for this blue point, is going to be equal to the same length and equal to the same 2a. That's a major property of an ellipse, because definition tells us distance is a sum of whose distances from 2 fixed points, and these are my 2 fixed points, is a constant. So sum is not changing. Well, what kind of curve I'm going to have? Well, I'm going to have something like this, guys. I'm not going to continue drawing these distances. I'm just going to draw the whole thing. I'm going to get something like this. And the object is called an ellipse. Well, you see, it looks like a squeezed circle. And that's just kind of how we realize, like, in nature definition of an ellipse, of how build an ellipse. Okay, now, well, is it going to be important how far away these focal points are? Focal point 1, focal point 2. Well, I'm going to draw 2 pictures with focal points far away and with focal points close to each other. Let me kind of choose 2 points here far away. And I'm going to use not very long string. I'm going to draw a picture looking like this. So The string is not very long and the focal points are far away, focal point 1 and focal point 2. And two focal points which are close. And let's consider the same length of a string. So what I'm going to have, guys? I'm going to have an ellipse which is almost like a circle. Well, it does not look like a circle on my picture, but kind of, sorry. This ellipse is going to be almost like a circle. So closer these focal points, more kind of round is going to be an ellipse. Further away, more squeezed it's going to be. Well, of course, everything depends on how long is your string. For example, these 2 points, if your string is very, very long, like this long, is going to give you an ellipse and a circle also. But let's say if the string is a little bit longer than the distance between focal points, then if focal points are far away, they are going to give you very squeezed ellipse. If they're close to each other and the string is still like same length, it's going to give you like more round ellipse. Okay, now what is going to be an equation of an ellipse? We know that equation of a circle is something like this: x squared plus y squared equals a radius squared, right? That's equation of a pure circle. Well, when circle is going to happen to an ellipse? Well, when you put two focal points in the same point, right? If you merge them together, if you merge these focal points together, you are going to have a circle. Circle is going to happen when focal point equals to each other. And you are going to have something like this. You put like your string at the same nail and put your pen over here and just go, and it's going to make a circle, right? But what is going to be equation of something like this? Well, let's recall actually how we kind of normally get equation of a circle. Remember that we were doing a little bit of geometry. That's what I'm going to do, guys. I'm going to draw a number plane and obtain equation of an ellipse. And let me first label my focal points. Let me label focal point 1. Label it a little bit off, like over here, focal point 1 and focal point 2. What I did, sorry, my focal point 2 is farther away. I'm going to divide the distance between focal points over here in half, right in the middle. And I'm going to put my y-axis right in the middle. So that's going to be focal point 1 and that's going to be focal point 2. Okay. And this distance, I can measure it. I'm going to label it as C, distance C. So what is going to be the coordinate of this focal point? Well, x coordinate is C, y coordinate is 0. For this focal point, because it's negative C over here, x coordinate is negative C, y coordinate is 0. Now imagine that I consider a point on my ellipse somewhere here, right on y-axis. So what I'm going to, what is going to be true about this point? Well, let me do the connection of the string to this point, right? What I'm going to have, guys, for this point. For this point, I'm going to have a distance over here, right? And this one is C. What is going to be the length of the rope? The length of the rope, I know the length of the rope is going to be equal to A, right? Well, if you look at this picture, we're going to have two triangles over here, and this is going to be like equal triangles, right? Over here, triangle with origin at the vertex, and over here. You see that actually in these two triangles, this is going to be A. If the length of green string is 2A, then half of it is going to be just A. So I have C over here and I have A over here. And because my triangle is a right triangle, I'm going to have this side over here, and that's going to be side, let's label it side B. I'm going to label side B. Remember that for right triangle, we can write down the Pythagorean theorem that B squared, that's side B, plus C squared, that's side C, right, equals A squared. I'm going to, write down from this that B squared equals A squared minus C squared. Eventually, I'm going to use it, but not right now. Right now, I'm just going to kind of put it apart over here. So now let's imagine any other point on my ellipse. For this point, everything is clear, like the coordinates are like this and we have everything connected. But imagine that we have another point on ellipse, point somewhere here. And this point has coordinates x and y, just arbitrary point on an ellipse. what is going to be the distance from the first focal point and the distance for the second focal point? Let's write down distance 1 equals, remember distance formula. The distance formula is, well, I'm going to write down general distance formula first because I'm pretty sure that everyone forgot it. If you have 2 points, x with coordinates x1, y1, in the coordinates x2, y2, then the distance is going to be x2 minus x1 squared plus y2 minus y1 squared. Sorry, my square is. And in my case, it's going to be, well, what is my x and y? My x and y are just like x and y. So x2 and y2 are x and y. And x1 and y1 is going to be my first focal point minus c0. So I'm going to have x minus c squared plus y minus 0 squared. If I simplify it a little bit, I'm going to get x plus c squared plus y squared. That's my distance 1. From my point on my ellipse, from the point on my ellipse, and like to the focal point. Now, what is going to be distance 2? Well, distance 2 is kind of using the same formula, but the focal point is different. It's this focal point, right? Only difference here is going to be that it was minus c over here, and there's going to be plus c over here. Well, that means that it's going to be x, not minus c, but just minus c. Too many minuses. And the y is going to be still minus 0. That's my second distance. I know that for the ellipse, the sum of distances is equal to the length, which is 2a, right? So distance 1 plus distance 2 supposed to be equal to the same length constant. And I set up this constant to equal to a. So I'm going to just combine these 2 square roots into the one formula. So I'm going to have x plus c squared plus y squared 1 and x minus c squared plus y squared number 2 and equals to a. Well, usually in equation, I don't like to have square roots. So what I'm going to do, I'm going to actually move one of my expressions to the right side and square both sides. This way, I'm going to get rid of the first square root. I'm going to keep the first square root over here, x plus c squared plus y squared. And the second square root, I'm going to just move to the right side over here, minus a square root of x minus c squared plus y squared. Okay, now I'm going to square both sides of this equation. And over here, square is going to eliminate square root. So I'm going to have x plus c squared plus y squared, right? What I'm going to have on my other side? My other side is going to give me the square of this, which is 4a squared, right? Minus 2 by 2a and the square of x minus c squared plus y squared. And it's going to be plus, and the square of this square root, which is going to be x minus c squared plus y squared. Well, expression is still too long. It's not equation yet, but I'm going to keep modifying it. First, I'm going to cancel certain stuff here. For example, I do have y squared here and y squared here. I'm going to cancel it, right? Now, if I open this parenthesis and this parenthesis, I will be able to cancel something too. I'm going to open parenthesis and cancel right over here without rewriting everything because I don't want to rewrite this long square root. So for example, this one is what? X squared plus 2xc plus c squared. And this one is x squared minus 2xc plus c squared. So what I can cancel c squared on this side, and I can cancel x squared and this side, right? For this one, for these two terms, I cannot cancel them because they do have different signs, but I can combine them together on one side, right? And that's what I'm going to do. I'm going to bring this minus term over here and write it as 4xc term. Now, I'm going to also bring this term to the right side, to the left side, sorry, minus 4a squared. And on this side, I'm going to have minus 4a, a square root of x minus c squared plus y squared. Well, I just need to eliminate one more square root, and I'm going to be then very happy about this, right? Well, to eliminate this square root, I'll need to square everything again, like my left side and my right side of the equation. Well, let's just kind of do it. There is no other way to get rid of it. I'm going to square now this expression and this expression. I'm going to have lots of calculations, but eventually we are going to have a very nice equation actually. So for 4 squared is 16, right? X squared is x squared. This is c squared, right? Then minus 2 4xc, the formula, right, by 4a squared, this multiplication, and plus 16a to the power of 4. Square of 4 is 16, and square of a square is a to the power of 4. Over here, I'm going to have 16 minus squared is going to give me a plus, then a square, because there is going to be like square of a, right? And the square of square root is just going to be expression under the square root. So it's x minus c squared plus y. Well, we're almost done. We just need to do some cancellations, and that's going to give us an equation. Let me see what we can simplify right now. I think I'm going to open this parenthesis on this side and kind of now match the terms on this side and then that side. So I'm thinking to first copy the left side, 16x squared c squared minus, and what I have 16, 4 by 4, and 2 is going to give me 32 xc by a squared. And here I'm going to have 16a to the power of 4. What I'm going to have on this side? On this side, I have 16a squared, and I'm going to open this parenthesis. So it's x squared minus 2xc plus c squared plus y squared. Well, I'm going to continue working on this side, distributing this 16 over each of these terms. So I have 16a squared x squared minus 32 a squared xc plus 16 a squared c squared and plus 16 a squared y squared. Move it a little bit. What do I have on this side? I'm just going to copy the left side. So 16x squared c squared minus 32xc by a squared plus 16a to the power of 4. Now, guys, I'm going to start canceling here. For example, I'm going to see that this term 16x squared c squared is the same as 16ac squared. So I'm going to cancel it. Next term I'm going to cancel is 32 term, minus 32 term xc a squared and xc a squared minus 32. So I'm canceling it too. Well, actually, that's all I'm going to cancel. I'm not going to cancel anything else. Guys, what I'm going to do, I'm going to just copy the expression I have. So I have 16a to the power of 4 here. On this side, 16 repeated in both terms. I'm going to, let me label them differently. Like this term and this term both have 16, right? And then both have a. I'm going to write down a squared. And here, x squared plus y squared, right? I missed something. Doesn't look like. Looks like I'm getting equation of a circle somehow. I'm missing something important here. I'm trying to figure out. Aha, yeah, guys. I think I should not cancel the term 16a squared c squared and 16x squared c squared. I kind of decided to cancel it, but actually they were like, I was supposed to cancel this term with it. I'm sorry. I'm going to fix it. I think when I was canceling, I underlined the wrong term probably. Let me erase this. Well, I'm going to return it back. So it's going to be what? Oh, sorry, let's use a green marker. It's going to be what? It's going to be 16 a squared c squared, right? So the 16x squared c squared is going to cancel with this term actually, because that's 16x squared. Oh no, it's not going to cancel with this term. It's actually going to cancel with no terms. Let me copy it again. I was looking at similar terms, and it's 16a squared x squared. Okay, sorry. I think I was trying to cancel too many terms. Actually, there is only one term I was supposed to cancel, and I decided to cancel all of them. Now, what I'm going to do, I'm going to just keep the term I canceled. So I did not cancel this one, actually. 16x squared c squared. What I'm going to do, the only term I canceled so far is 32. And what I'm going to do, I'm going to move this term 16 over here to this side. And I'm going to keep 16a over here. So it says 16a to the power of 4 equals. And what is not canceled here? 16a squared x squared plus 16a squared c squared minus 16x squared c squared. It looks like all of them are having something in common, but not kind of like everything in common. And the last term is a 16a squared y squared. So I copied this term, I did copy this term, like 16c squared. I did copy this a squared x squared, a squared x squared. And I did copy this one with minus. Well, what I'm going to do, I'm going to unify a couple of terms here. So I'm going to unify terms with x, these terms together. So what I have, 16x squared, and here a squared minus c squared. Well, it's a squared and minus c squared. Okay, I'm going to move this term 16a squared c squared to the left side. So I'm going to have 16a to the power of 4 minus 16a squared c squared equals 16x squared a squared minus c squared. I copy this one, and plus 16a squared y squared. Well, what I'm going to do first, I'm going to recall that somewhere in the beginning I told that a squared minus c squared is going to be b. B is going to be the distance to the middle of the top of the ellipse. So I'm going to label it over here as b. B squared. Okay. And if you look at this expression and take away 16 and a squared, we are going to have a squared minus c squared. And again, a squared minus c squared, I decided to label as b squared. I need this, well, to make equation looking nicer. So I have 16a squared b squared equals 16x squared b squared plus 16a squared y squared. We're almost done. Now, what I'm going to do, I'm going to cancel 16 everywhere because kind of repeated everywhere, right? Now, I'm going to divide this expression, the left side and the right side, by a squared b squared. We're almost done. Here, I'm going to get just one, right? On this side, b and b squared are going to cancel, and that's going to be x squared over a squared. Plus, here, a and a squared are going to cancel, this a and this a. And I'm going to have y squared over b squared. And that's a final equation of an ellipse. So this is going to be equation of an ellipse. So what we have over here, what is a here? A is half of the length, right? So a is length of the rope over 2. What is b? B squared equals a squared minus c squared, where c is position of a focal point. Okay, so these are two kind of notes. What are a and b? Very good. That's equation of an ellipse. Well, will I ask you to memorize how we obtain the ellipse? No, but you will need to understand that ellipses are not coming from nowhere. Actually, they're obtained kind of geometrically and mathematically. Very interesting note over here, guys. It looks like equation of a circle with radius 1, right? The only difference is that circle does not have anything in denominator, and ellipse is going to have. If in denominator you have a same number, like a equals b, you are going to have a circle. Let's look over here when a is going to be equal to b. Well, if b squared equals a squared minus c, a equals b only if c if C equals 0. So if your focal points are matching F1 equals F2, then C equals 0 and B and A are equal to each other, and we are going to get equation of a circle. We're going to have like x squared over a squared plus y squared over a squared. You bring a squared to the left side, and that's a squared equals x squared plus y squared. You see? Okay, common sense is working. So our new equation is matching our previous ones, which we had for a circle. Now we are going to kind of maybe develop a couple of equations of ellipses. So for example, I'm going to consider a couple of examples. So example number one. Imagine that somebody gives us description of an ellipse. So somebody tells, well, imagine that you have an ellipse with center at origin and next characteristic. This point is like the vertex of an ellipse, is 4 units away from the center of an ellipse. And the focal point is 3 units away. So that's a focal point. I'm going to label it F2. Can you find what is equation of this ellipse? Can we? Well, for equation of this ellipse, we will need to know what A and B. So let's start with finding A. How do we find A? Well, let's look at this equation we have. 1 equals x squared over a squared plus y squared over b squared. This point over here has coordinates, some x, in our case 4, and y is equal to 0. If I plug y equals to 0 over here, what I'm going to have? I'm going to have 1 equals x squared over a squared, from where x equals a. So actually, intersection of ellipse with x-axis is going to give us a for the ellipse. So we already know that a here is equal to 4 because it kind of equals to 4. Now, what is b? Well, to calculate b, we are going to use this formula that b squared equals a squared minus c squared. A squared is going to be 4 squared, and c, this is going to be our c, right? Distance from the center of an ellipse to the focal point is going to be 3 squared, which is going to give us 16 minus 9, which is going to give us 7, right? But that's not b. B is going to be square root of 7. Here we are using a principal root because we just need a numerical value. We are ready to write down the equation of this ellipse. X squared over a, which is like 4 squared, right? Plus y squared over b, which is square root of 7 squared, equals to 1. If you don't like to have squares in denominator, you can simplify it as x squared over 16 plus y squared over 7 equals to 1. Otherwise, that's equation of an ellipse. Now, what if somebody gives us equation of an ellipse and they're asking us to graph it? Example number 2. So here we were given some characteristic of an ellipse and we were building equation. But imagine somebody gives us equation of an ellipse. X squared over 25, for example, plus y squared over 9 equals 1. Can we graph this ellipse? Well, let's recall what are important points on ellipse graph. Well, if you kind of graph just any arbitrary ellipse, you know that there is going to be over here a point with coordinates A0, right, which is called the vertex of an ellipse. It happens because when you set up y equals to 0 to the standard equation of an ellipse, you are going to get like this, the A. If you set up y equals 0 over here, what are you going to have? You're going to have x squared over 25 equals 1, from where x equals plus minus 5, right? Y equals 0. This is kind of intercept. So this is going to be plus 5, the point, and this point is minus 5, right? If you set up x equals to 0, y-intercept, you are going to have y squared over 9 equals 1, from where y squared equals 9, or y equals plus minus 3, and that's going to be x-intercept, 3 and minus 3. Knowing these 4 points, you can just draw something elliptical and say, yeah, that's my equation of an ellipse. Okay, sorry. Well, more complicated ellipse, a little bit more complicated ellipse. What is going to happen if somebody does not give you a straight equation of an ellipse? Example number 3. Somebody gives you an equation looking like this. 9x squared plus y squared equals 9. And you think, okay, normally equation of an ellipse looks like x square over something, y square over something equals to 1. And here we don't have this. What are we going to do, guys? To get 1 here, we just need to divide by 9 left and right side of our equation. And we are going to have x squared, because this one divided by 9 is just going to be 1, and y squared over 9 equals to 1. Now, we'll need to find the vertices and make them like points on our graph and connect them in a smooth line. So I'm going to set up x equals 0. Then I'm going to have y squared over 9 equals 1, from where y squared equals 9, and from where y equals plus minus 3. So these are y-intercepts. Y equals 0 is going to give us x squared equals 1, right? If you set up y equals 0, which is going to give you x equals plus minus 1, even faster. Now, let's graph all these points. Y is plus minus 3. And x is plus minus 1. 1 minus 1. I'm going to just connect them with a nice smooth line. Okay, guys, remember the previous ellipse we had was kind of horizontal one. It was squeezed from the top, right? And this ellipse is squeezed on sides. Well, what is interesting, guys? Focal points are always going to be located on a long axis of an ellipse. And this long axis is called major axis. And the short axis of an ellipse is called minor axis. Focal points are always sitting on major axis. Okay, I did not ask you to find focal points, so you don't need to do this. Just like remember that. But if I ask you to find focal points, how would you do that? Remember that b squared equals a squared minus c squared. Well, that's just a triangle with focal points. This is C, right? That's going to be, this is going to be B, and that's going to be like A. Well, on my picture, what is what? Well, I know that A is like this distance, right? What is B? B is this distance. And I know that also A is this distance too. So how to find C? Oh, just let's plug everything in here. My B is equal to what? B is a short, half of the short axis. So it equals to 1 squared. My A is equal to 3 squared minus C. I don't know C. Well, I'm going to just calculate what is C. That's 1 equals 9 minus C squared, from where C squared equals 9 minus 1, right? Which is equal to 8. Or C equals plus minus square root of 8. Where is this square root of 8 going to be? Remember, I said that focal points are always sitting on a major axis. So that's going to be the first one, 0 square root of 8. And that's going to be the second one, 0 minus square root of 8. That's focal point 1, let's say, and focal point 2. You can label them as you like. Okay, well, that's all about ellipses. So basically, guys, what do you need to know? You need to know how to graph an ellipse and how to get equation of an ellipse from properties of an ellipse. Okay, how to graph is examples 3 and 2, and how to get an ellipse from kind of properties, like if somebody gives you focal position or vertex position, you also know. Okay, that's all. I'm going to return back to ellipses in section 11.4, where I'm going to explain like how do we graph shifted ellipses. And we're going to talk a little bit about physics of ellipses. But for now, that's, I think, going to be enough for us to graph ellipses. Okay.